is that? Look at it. 4 pi over 6 is actually 2 pi over 3. Holy crap. So 4 6, what's this one going to be? Right here. What is it? 5 6. 5 pi over 6. 6 pi over 6 is what, everybody? Pi. And then what's the next one going to be? 7 pi over 6. 8 pi over 6 is actually what? 1, 2, 3, 4. See, I already have to count it out. It's actually 4 pi over 3, which is 8 pi over 6, right? And this is 3 pi over 2. What's this one going to be? 7, 8, 9, 10, 6, which is actually what? 5 pi over 3. This is, bless you, going to be 11 pi over 6. And then 12 pi over 6 is actually what? 2 pi. So see, it all goes around. And this is why I told you, do you understand why I kept saying fractions are your friends? We're going to deal with fractions all the time. That's all we're talking about right here. Okay? Now, how's all this going to translate? Oh, the pi over 6 angles are, what are their ordered pairs? Well, their ordered pairs are square root of 3 over 2, 1/2. That's a pi over 6. And then this was a pi over 3, and then that was a pi over 2, and that's a pi over 3. Oh, here's another one. What's this 5 pi over 6 going to be? Negative square root of 3 over 2, comma, 1/2. Right? Because it's right here. What's the 7 pi over 6 going to be, folks? Negative, negative. Negative square root of 3 over 2, comma, negative 1/2. And then 11 pi over 6 is going to be square root of 3 over 2, comma, negative 1/2. When we get this on the big unit circle, it's going to completely make sense to you. I promise. Okay? But remember, pi over 6 goes with square root of 3 over 2, comma, 1 over 2. That's its order there. Okay? All right, we're ready to go back to the main circle. Take us back to the original unit circle. Now, if you notice, I use colors, and I have to because I'm visual. And it will help some of you to use different colors. I've used green, I've used blue, I'm going to use red. Do you guys see the skinny X? The tall skinny X? Okay? It is right here. Right there. Y'all see it? Hold on. That was bad. Alright, and then here. You don't have to draw that in there, but I just want you to be aware of it because some folks, well, you'll see. Alright, so let's go with red. Alright, so if I'm focused on my skinny X, then which angles are we talking about? Pi over 3 angles or pi over 6 angles? Pi over 3. Alright, so we know that. This is pi over 3. What do you think that's going to, what that measure's going to be? What's a normal, common angle that we encounter when we're dealing, what? 6 degrees. Alright, keep moving over to the other side. If that's 1/3, then isn't this going to be 2/3? And what is 90 plus 12? If we're counting 60s, then this angle is going to be what? What's two 60-degree angles? 120 degrees. And then we have our third 3 over 3 would be our pi, right? All right, let's go to the bottom. I have patience. All right, so we've got the top back down here. So we've got 1, 2, 3/3. What's this one down here going to be? 4/3, 4 pi over 3. What's 180 plus 60? Come on, y'all. 240 degrees. 4/3. What's this next one over here on the left in the fourth quadrant? This was 4/3. This has to be 5/3. 5 pi over 3. And 180 plus 120 is 300 degrees. And then we would have 6 pi over 3, which is 2 pi, 360 degrees. You guys see it? Okay. We're going to go back and put the order pairs in just a minute. So I've got green, red, and blue. Okay. Last ones. Now we have to put in the what's? The 6 pi over 6. All right, here we go. Pi over 6 is first. What do you think that angle measure is going to be? Look at those angle measures. 30 degrees. Guys, did we go over this in geometry? 30-degree angles, 45-degree angles, 60-degree angles, and 90-degree angles. Didn't we go over those a lot where we're dealing with right triangles? You're going to find in a couple of weeks, this all goes back to right triangles. Every bit of it. So pi over 6 is 30 degrees. All right, so here's 1 6 here, 2 6 here, 3 6 here, 4 6. What's this one here? 5 pi over 6. And me, 120 plus 30 or 180 minus 30 is going to give you what angle measure? 150 degrees. Is everybody with me? You seeing where I get these? Alright, so we've got 5 6 up here, 6 6. What's this one going to be? 7 6. Good. Which is going to be what angle measure? What's 180 plus 30? 210 degrees. So 7 6, 8 6 is here at 4/3. 7, 8, 9, 10. What's left? 11. 11 pi over 6. And then what's 40? I think backwards on this one. 360 minus 40. 3/3. Holy moly. I ain't going to remember all that. You're going to count off by 30s. You're going to count off by 45s. You're going to draw your X's and you're going to go from there. It's not difficult. Okay? Alright, here we go. Now let me show you the pattern. Does everybody have the third and fourth quadrants? Fill in. Okay. Let me show you the pattern. You see it all at once. Because it's a huge job. It's a huge picture. That's, you don't like that? Because I didn't hit the right button. Sorry. I apologize. Alright. Now, let's think about the order pairs. We got to put, I have to put square root of 2 over 2, square root of 2 over 2, right? What was the order pair for 0? Let's go there. For 0, it's 1 0. 4, 90 degrees, it's what? 0 1. 4, 180 degrees? Negative 1 0. And for 270? 0 negative 1. Okay, we got those order pairs in. Let's go for our 45-degree angles. You should already have them in there. Positive, positive, square root 2 over 2. Okay, that's a lot of stuff. This one's going to be negative square root 2 over 2, positive square root 2 over 2. Correct? This one down here is going to be negative, negative. Yes? And then this one's going to be positive, negative. That's going on. Positive, negative, right? All right. Now let's go for the 30s. We've got everything filled in except for our 30-degree angles and our 60-degree angles. Guys, this is where it gets easy. Look at the pattern. This is the pattern that's symmetrical. What was the pi over 6 order pairs? Square root of 3. It was square root of 3 over 2, and then 1/2, wasn't it? Right? And then, if you look back at your pi over 3, that was 1/2 square root of 3 over 2. Folks, do you see the pattern? You don't have to learn anything. Look at the pattern. 3, 2, 1, and go back to go. 3, 2, 1. You guys see that? Wow. So see, you don't have to learn it. That's all you have to learn. That's it. Now, how is this all going to translate over into the second, third, fourth quadrants? What's going to be the only thing different? The signs. Oh my gosh. Seriously? Yeah, seriously. Let me fix this because I have paper in red. 3, 2, 1. All right, here we go. So I'm going to fill in all my reds since I have my red pen. So what will 2 pi over 3? What will its order pair be, guys? Talk to me. I think you said negative 1/2. Positive square root of 3, right? Okay. What will it be at 4 pi over 3? Negative 1/2. Negative square root of 3 over 2. Well, what will it be over here at 5 pi over 3? 1/2. Negative 3 over 2. Square root of 3 over 2. Bless you. And then go back through and plug in or fill in the pi over 6 increments. What will 5 pi over 6's terminal point be? Say louder. Right on. Negative square root of 3 over 2, 1/2. And then of course the signs just change with each quadrant. Negative square root of 3 over 2 would be negative 1/2. And positive square root of 3 over 2, negative 1/2. Guys, look at that pattern. If you take that unit circle out of your binder, out of your notebook, and you fold it on those quadrants and hold it up to the light, especially if you use colored pencils or markers. If you hold it up, you're going to see that all of these, do you see what happens with the pi over 6's? Okay? 3 over 2, 1 over 2, 3 over 2, 1 over 2. The same thing with the blue angles, the pi over 4's. Okay? But you're going to focus on the x's, and that will help you fill in the unit circle. Now, just because Ross Neely missed this, you're not going to have your first quiz until Friday. Friday's quiz will be quadrant 1. You have to fill in everything on quadrant 1. Meaning, you have to fill in quadrant 1. You got to fill in all of your degree measures, all of your radian measures, all of your order pairs. Okay? I'll grade it, give it back to you. On Monday, your quiz will be quadrants 1, 2. On Tuesday, I'll grade and give it back. On Tuesday, quadrants 1, 2, and 3. On Wednesday, 1 through 4. And I'll probably put you again on Thursday. Folks, what am I setting you up for? I'm setting you up to remember it, to learn it. With this. Here's what we're going to do with this. I want you to look at some of these problems, and we're going to figure out how to find these terminal points. Okay? So if I were to give you, and I don't think we've done this, if we have, tell me. So find the terminal point of the following. Same thing we've been doing, but new numbers, okay? Negative 4 pi over 3. Now, you can have your unit circle beside you right now, but you have to get used to not having it. And in order to get used to not having it in front of you, I'm going to draw this thing below. This has 3 in the denominator, right? What kind of X do I need to draw?
Little skinny.
The tall, narrow one, bless you. Okay? I know that's not perfect. Some folks have found, because do you guys get caught up in, would you look at this as going 1, 2, 3, 4, 5, 6, 7, 8? Some of you look at it like that. Some of you did. I saw some of you go, raise an eyebrow. Okay. Do this for me. When we see thirds on the bottom, mark out the y-axis. Because when you mark that out, now we can focus on three pieces of pie. 3 pieces of pie on top. Y'all see them? How would I graph -4 pi over 3? Which way am I going to rotate up or down? I'm going to rotate down. So I'm going to go 1, 2, 3, 4. Holy moly. What's that ordered pair? Now is when you can refer back. For today, you can refer back to your unit circle. That's a power of 3, 3, 2, 1. So that's going to be negative square root of 3 over 2 positive 1/2. Is that what you found? Yeah? Look at it. Oh, hold it. 3, 2, 1. Yeah, my fault, y'all. I'm sorry. Negative 1/2. That's not bad. Got it? It's called me out with your expression, your silent expression. Oh, still. That's what his face just said. That's like it. All right, let's look at another one. I'm sorry, y'all. There's another one. 5 pi over 3. Thirds. What kind of X? Okay, tall. Mark out your y-axis if that will help you. Rotating up or down on this? Rotating up. All right, here we go. Here. 1, 2, 3, 4. How many of you had that rotation? Okay, now. Did you have for your ordered pair 1/2 negative square root of 3 over 2? How many of you had that? Hands up. Good. Do you have questions? Is this possibility? I see. Coincide means the same thing. You know, say what? Not really sure what you said. Here we go. Here's another one. -5 pi over 6. Tell me what that terminal point will be. Draw the spiral and find the order. How many X's? 2 X's. You gotta have 2 X's for this pi over 6 angles. Do we observe the X and the Y axes in pi over 6 angles? How many pieces of pie do we have to have on top?
6.
We have to have 6. So I've got 1, 2, 3, 4, 5, 6. Let me ask you again. Do we observe the X and Y axes on this one? Yeah, we have to, because that's what helps create the 6 pieces of pie. Okay? -5 pi over 6. There we go. Rotate up and down. Rotate down. Folks, where's that going to land? Which quadrant? Quadrant 1, 2, 3, 4, 5. It lands in quadrant 3. Order pair. Don't say it out loud. Did you get negative square root of 3 over 2, whatever? Negative square root of 3 over 2, negative 1/2. Does anybody notice how I go, every time I get ready to do the order pair, I go, bump, bump, bump. Do y'all notice I do that in the first quadrant? Why do I do that? Because I'm going in my head, 3, 2, 1. And then I have to translate it over here. Okay? I know that my 6 are the 3. They start with the 3. My pi over 4, those are easy. Those are pi over 2 over 2, right? Or square root 2 over 2. And then my pi over 6, pi over 3 angles are the 3, 2, 1. That didn't make any sense at all. I know what I'm trying to say. Sorry. Just delete this part of the video recording. All right. Questions? Here we go. What about this one? Draw the angle. Let's see. Pi over 12. What? I saw that face. Well, what in the world? Is it asking for an ordered pair this time, or are we literally just drawing the angle? We're literally just drawing the angle this time, okay? How many pieces of pie does the snake have to have on the top? Has to have how many? How many? Has had 12. Why 12? Because that's the denominator. This has to have 12 pieces of pie. Why don't you do it? You probably could because I picked a crappy number. Let's go with 13 pi over 12. That's just 40. 40. There's still 12 pieces of tie, no matter how much on the top. All right, here we go. How am I going to draw that? Oh my Lord, am I really going to have to draw that exact, perfectly? Well, let's think about it. What you got? Pardon me?
There's 12 in the denominator, you have another x. Because when you get 3 in the denominator, you have a tall x.
Oh.
6.
Okay, you're thinking about drawing the perfect X, the skinny X, the fat X. Okay.
Now that you got 12 in the denominator, you add another x.
No, I'll show you a shortcut. Write this down. Miss Perry's showing you a shortcut. I never do this. Guys, if we're dealing in 12ths, then if I go this way, what's this number going to be in radians? If it's in terms of 12ths, pi is going to be 12 pi over 12, won't it? Won't that be pi? 12 over 12? Where will 13 pi over 12 land? In which quadrant? In the third quadrant. Guys, I don't care about these being exact as long as you do this. Because if we've got 12 pieces of pie on top, plus 1 would give me 13 pies, right? This right here, that's all I need to see. I need to see where these weird denominator angles, where they land.
So we just need to put like
You just draw an angle. You see how I drew the red angle? Draw the angle and put a point on there, and that's where 13 pi over 12 will land. Is in quadrant 3. Does that make sense? So what do you really have to know about these? You really have to be able to work with what? Fractions. I told you you would. Let's do another one. There's a reason I'm doing these. What is this? Example 5.
Miss Perry,
Yes, ma'am.
would you send Sogan Greer to Miss Clark's office, please?
Yes, ma'am.
Thank you.
Let's go with drawing the angle. Still drawing the angle, drawing the spirals.
that room they were renovating.
It used to be a storage room, and now it's across from the office. Her name's on the side of the wall. All right. Or it just says in principle, it says something on the wall. Why didn't you? Here we go. All right, so let's draw this angle. Let's go with. Draw that one for me. Do you see what I did? The thing you need to keep in mind is pi and 2 pi. All right, if my denominator is 5, then 5 pi over 5 is pi, right? And 10 pi over 5 is 2 pi, correct? All right, so watch what happens. I'll rotate up or down. I'll rotate it up, and notice that I put 2.5 pi. Why did I put that there? Because that's halfway mark between 0 and 5, correct? All right, watch what happens. Here we go. Here's 10. Here's 20. How much farther do I go to get to 23? 3 more. Which is going to be somewhere over here, isn't it? It has to be past 2.5. What do? Draw the arrow. Draw the point. There we go. How many of you had your angle land in the second quadrant? Very good. Very good. And if you didn't, would you be able to figure it out next time? Possibly. Very possible. Okay? It's just fractions. It's all we're dealing with. Well, I did because I did. Write that down too beside Miss Perry shows. I always, sometimes you have big rules sometimes. Sometimes. Where's my butt? Here we go. How about negative 11 pi over 7? Do that one. Are we rotating up or down? We're rotating down. Folks, if we rotate down, then I'm going to have 7 pi over 7 pi. When I round back around, I'll have 14 pi over 7. I put it on top of my x-axis this time. Usually I put it underneath. Why did I put it on top this time? Because I'm rotating down this time. Okay? Do I even go that far there? No. Where does this land, this negative, where's the 11 land? All right, let's go. We're going to rotate around. We get 7, we get 10.5. Would that be 11? Okay. And we have to draw that angle in there from the origin. There it is. And then that's it. I don't know the order pair. Do we care about the order pair? No. We just care about where that's going to land. Yes, ma'am. How did I get to 10.5? I know that 7, half of 7 is 3.5. So I took 7 plus 3.5, which is 10.5. That's how I got it. Okay? And yeah, I know it's a decimal within a fraction and it's weird. But I got to think what's half of 7. Okay? All right. What you're going to do for me for homework? All right, worksheets for homework, guys. On number, this is class work homework. You can get this done before you leave. Please work together. It's what you're going to do in college. I ain't stupid. I did it. You have to sometimes, if it's not for your classmates, you don't know how to, well, don't be classmates. Not saying, not cheating, but you rely on your classmates big time. All right, on the worksheet, folks, I want you to give the order pairs. You're going to, number 1, draw the spiral angle, okay? That's the first thing you're going to draw for all of them, okay? For 1 through 10. The second thing you're going to do, you're going to write the ordered pairs for, hold up, I'll get to it. Write the ordered pairs for the terminal points. All numbers 1, 5, 6, $8.92. Does everybody understand? Oh, here's the back. Yeah, there's,
He just put mine in the back.
there's the back. You do front or back?
Barry,
Yes.
have Kellen roll, please.
Yes, ma'am.
Thank you.
So,